Today in Math 20-1, we're going to look at topic 6.1, reducing rational expressions. In example 1, we're going to look at determining the non-permissible values, sometimes called NPVs. First of all, you cannot have a 0 in the denominator. If it is, it's undefined. For instance, you'll never see a fraction like 7 divided by 0. In our first example, 5t over 4sr squared, s cannot equal 0 or r cannot equal 0. If either s or r are equal to 0, then the whole denominator will be equal to 0 and our rational expression will be undefined. In our second example, we have x times 2x minus 3 in the denominator. That says to me that x or 2x minus 3, neither of them can be equal to 0. Well, x cannot equal to 0 is one thing. 2x minus 3 means we have to solve for x. So add 3 to both sides, and you're going to get 2x cannot equal 3. Divide both sides by 2, and x cannot equal 3 over 2 or 1.5. On our third example, our denominator is p squared minus p minus 12. And to factor that, we're going to get p times p, and we're going to get two numbers that multiply together to give me negative 12 and add up to negative 1, and that's got to be p minus 4 and p plus 3. Now, p minus 4 cannot equal 0, which means p cannot equal 4, and p plus 3 cannot equal 0, which means p can't be negative 3. Those are our two non-permissible values. So again, 7 divided by 0 up at the top means it's going to be undefined. Okay, with example 2, it asks us to simplify each rational expression. In A, we have 3x minus 6 over 2x squared plus x minus 10. In our first numerator, 3x minus 6, well, we can factor out 3, leaving us with 3 times x minus 2. In the denominator, 2x squared plus x minus 10, we're going to have to decompose that, meaning we got to find two numbers that multiply together to give me negative 10 and add up to my middle term of positive 1, negative 20, and add up to 1. And that's going to be positive 4, positive 5, and negative 4. Eesh. So you're going to end up with 2x squared plus 5x minus 4x minus 10. Now I'm going to factor an x out of the first two terms, leaving me with 2x plus 5. And I'm going to factor a negative 2 out of the second two terms, and I'm going to end up with 2x plus 5. So my bottom denominator is going to end up being 2x plus 5 times x plus minus 2. So I'm going to put that over there. Now, next part, state our non-permissible values. 2x plus 5 cannot equal 0, or factors. Number 1, factor. We've done that. Second step, list our non-permissible values. So 2x plus 5 cannot equal 0. Okay, the third step is, of course, to reduce by canceling. So 2x plus 5 cannot equal 0. Which means if we subtract 5 from both sides, you're going to get 2x cannot equal negative 5. And dividing both sides by 2, x cannot equal negative 5 over 2. Our other non-permissible value is going to be 2. Next part, cancel the x minus 2's, and we're left with our final answer of 3 over 2x plus 5. Part B, 1 minus t over t squared minus 1. Well, the numerator isn't going to change, but the denominator, t squared minus 1, is a difference of squares. So we're going to write that as t plus 1 times t minus 1. Now you have to remember something here. 1 minus t over t minus 1. Last year in grade 10 we learned that if you had Then backwards, like that, you could factor out a -1 from one of them. So negative t plus 1 on the top, if I rearranged it, over t minus 1 on the bottom. If I factor a -1 out of the top, it would look the same as the bottom. Therefore, when you see them reversed, 1 minus t over t minus 1, it's actually going to cancel out to leave you with a -1. So that's what we got up there. So it leaves us our final answer is -1 over t plus 1. And remember here again, if I had t plus 1 and t minus 1 as my denominators, we'd also have to say that t cannot equal -1 or t cannot equal +1. Here we are in example 3, rational expression with pairs of non-permissible values. When you see something like a denominator where you have 8x minus 6y, well, that can be factored into 2 times 4x minus 3y. And in a case like this, when a non-permissible value depends upon another variable, all you have to say is that 4x minus 3y cannot equal 0. You're done. That's all we expect. That's part A. Part B. Simplify the rational expression. Well, the numerator, 16x squared minus 9xy, is a difference of squares. So we'll express that as 4x minus 3y over 4x plus 3y. The denominator, 8x minus 6y, can simply be what we've already factored, 2 over 4x minus 3y. Now again, we have to say 4x minus 3y cannot equal 0. And I'm going to go on and I'm going to cancel my terms that are equal on the top and the bottom. And my final answer will be 4x plus 3y over 2. Part C says to evaluate the expression for x equals 2.6 and y equals 1.2. So we'll substitute. 4 times x means 4 times 2.6 plus 3 times 1.2 all over 2. If I multiply that out, I'll get 10.4 plus 3.6 over 2, which is 14 over 2, which is 7. Now we're asked to show 2 ways to determine the answer. Well, the other way would be to plug it into our original expression before we simplified it. This might help you understand why we simplify. If we take our 2.6 for x and 1.2 for y and plug it into our original equation, 16x squared minus 9y squared over 8x minus 6y, we're going to get a mess. We're going to get 16 times 2.6 squared minus 9 times 1.2 squared over 8 times 2.6 minus 6 times 1.2, and that'll clean up to be 108.16 minus 12.96 over 20.8 minus 7.2, which is 95.2 over 13.6, and if I divide that, I'm going to also get 7. So doing this 2 different ways shows you that both expressions are equal. So in summary, we find that a rational expression is an algebraic fraction of the form p over q, where p and q are polynomials and q cannot equal 0. A non-permissible value is a value of the variable that causes an expression to be undefined. For a rational expression, this occurs when the denominator is 0. Rational expressions can be simplified by factoring the numerator and the denominator, determining the non-permissible values, and then dividing both the numerator and the denominator by all the common factors. So your assignment then is to go back and do page 312, your turn, page 315, your turn, and page 316, your turn for tomorrow. And going on and doing page 317, 1 to 13, and 15 for homework for Monday.